All right, so a couple of things that, besides the obvious problem of having time, you guys need to understand that from now on, pretty much every day there's going to be two things due before class, right? There's going to be the pre-score from the one we just taught, and then the post-score from the one the time before, right? So you need to kind of plan according to that and make notes. Now, if you do them on your phone, that's fine. I have a lot of people that are doing them on their Chromebook, which is fine as well. They use their Chromebook computer or Chromebook camera to take a picture. That's fine as well. So yeah, but yeah, you're right. I will give you until the end of the period today to fix that because I got it up late. So, but that's today only. I did have a whole bunch of people that got 8s on their pre-score for number 1. I still have a few people that haven't turned it in. I'm not sure what that's about. But, all right, so it is 11:06 today. This is 4th period, and this is going to be questions 4.2, right? Okay. So, anybody have any questions on section 4.2? A little bit of quadratic formula. Yo, Flinders.
So like, I just have a general overall question.
Okay.
So one of my answers, I got -9 and then plus or minus square root of 105 over 6.
Okay, so that's that's actually a great question. -9 plus or minus the square root of what?
105.
105 over 6. Now listen. Over -6?
I just got 6.
It's -6?
I think
Did you? Probably like did the opposite way.
What number is right?
It was a -6 on mine.
Because it's -3, so it's got to be negative. Now listen. This is actually really important, so I'm glad Flinders asked this. When you look at this, remember, to be able to reduce it, it's got to be able to come out of there, there, and there. So unless I can whoop this, there's a 1 right there, right? I can't do that, you see what I'm saying? Can I whoop that 105? I know 5 works, but then that gives me 735 doesn't work, right? Now, there is one thing you can do, though. What is that?
Take out the negative.
Yeah, take out that negative. You never want to leave a negative in the denominator, ever. When I do that, this negative, because of this plus or minus sign, it doesn't matter, but I can take it out right here. Okay, and I would actually end up with 9 plus or minus the square root of 105 all over 6. And I'll bet you money that on the test, somebody screws that up and goes 3 plus or minus the square root of 105 all over 2. But you can't do that. Does that make sense? Okay. Anybody else? Dude, Barker, dude, turn around and be quiet. Turn all the way around, like put both feet.
I don't like that.
Put both. I know that because you want to turn around and talk so much.
It just feels weird.
Barker, or not? Sorry, Dixon.
So were there any on here that you could whoop? Because I was kind of confused how to do it, so I didn't whoop any.
I don't know. Did anybody run into one you could whoop?
There are a few.
Does anyone know what one it was? Can you go over it?
There was
It was
number 8.
153.
So 8 is whoopable.
I'm pretty sure.
Yeah, so is 9.
Okay, so let's look at 8. You paying attention, Dixon?
Yes.
Okay, so first rule is I want to go standard form, right? It's already in standard form, so we're good there, right? So I got A is 1, B is -6, C is 7, right? So I'm going to go the opposite of B, so I'm going to go 6 plus or minus the square root of -6 squared minus 4 times 1 times 7 all over 2 times 1, right? So that's going to give me 6 plus or minus the square root of something all over 4. Sorry, over 2. Not sure where 4 came from. 2 times 1 is 2. Okay, what's this?
36 minus 20.
8. Okay, so it's 8. Who's it for?
Taylor Keys.
Kai's in the back. Raise your hand, Kai's. There you go. Thank you. Alrighty, now So this is a good example. So I'm going to whoop this, right? And that's going to give me 6 plus or minus what? 2 root 2 over 2, right? Well, I can take a 2 out of everything, correct? If I take a 2 out of my numerator, that's going to leave me with what? 3 plus or minus the root of 2, because that 2 comes out as well, all over 2, and then that 2 and that 2 do what? They reduce out, leaving me with, that is my answer.
You triangle. I not simplify. I get for the most part there, and then I just
So you
go.
at first ignore like everything else and just do the radical.
Yep.
Okay.
And then simplify what's left after that.
Okay.
Okay? How about anybody over here? You guys seem to be all quiet and reserved and I don't know, Smedley, you okay? Because you're awful quiet.
What? Yeah, I'm good.
You've usually always got something to say. I mean, not a bad. I didn't say that meanly. I was just saying. Riley.
Okay, so you know how like the a cubed plus b cubed thing, how like even if it would like multiply to be positive, it's still negative in like the equation. Is that the same thing on this? Like, I just lost my train of thought. One second.
Now, what you need to understand is that is a pattern. That
Right.
doesn't matter what your A and B are. If you follow that pattern, it's going to be right. This one, though, you have to go by what's going on here. Thing you need to understand is if this B's negative, this B's the opposite of that. It's always going to be positive.
Okay.
But here, because I'm squaring it, it really doesn't matter. This number will always be a positive number.
Okay.
Okay? Now, something I didn't cover the other day that I was going to wait until I felt we had a better feeling for this is this. When you get to this step right here, okay, this number actually has a name. Does everybody know what it's called in this situation? It's what's called the discriminant. It's called the discriminant, okay? And what that does is it tells you what kind of answer you're going to have, okay? And there are 3 possibilities for a discriminant, okay? And all this is it's kind of a hint as to whether or not your answer could be right. Okay, now you're going to get a discriminant that's equal to 0, okay? I think we had one. Didn't we have one where my discriminant came out to be 0?
Oh, yeah.
Right? Which meant my plus or minus did what? It's just gone, right? So whenever my discriminant is 0, I'm going to get one answer out. If you'll notice, you only got one answer on that, right? Now, if you go back, these are all squared, right? Which means I should have what? 2 answers. So if I only got one answer out, what does that tell me?
It's 2 twice.
It's 2 twice, exactly. Okay? Now, from there, you're going to get a negative discriminant. If I ever get a negative as a discriminant, what does that tell me about my answers? It's going to have an I. Okay? And so what that is it is, you can either say it is a complex number. Sorry, you can say it's a complex number. And a complex number is simply a number that contains an I. Or you could say it is imaginary. Okay? But either way, you're going to get 2 of them. Right? Because you're going to get the plus version, then you're going to get the minus version, right? And then the other one is you're going to get a positive, and that simply means you're going to get 2 real solutions. Okay? And what that does, it just kind of tells you when you're done what you should have. So if we go back to this one, our discriminant was an 8, right? 8 is a positive number, which means I'm going to get 2 real solutions, which means my answer is not going to have a what in it? It's not going to have an I. Did we get 2 real solutions? Yeah, because we got what? What would the actual, if I wanted to write this answer out long ways, what would my answer actually be?
For the 0, 3 plus x equals 3 plus 2 squared 2
Square root of 2.
square root of 2 and 3 minus.
2 minus.
And that's going to give you your 2 real solutions. Okay, and that's just kind of an indicator to kind of guide you as you went. You go back to, what'd you say, 11, Flinders? Gave you a 0?
11.
So 11, you get a 0. I know that when I'm done, I'm going to only have one answer. Okay, yeah.
Did you want us to break it down further?
No. I'm a typical lazy student. This is what you're going to see. Because you don't, I mean, down the road we will go a little bit farther, but for right now I'm more worried about you being able to do this right there. Okay?
I forgot if you wanted.
Yeah, no, you're fine. No, if you did, that's fine. If you didn't, that's fine too. I don't care. Yeah, Smedley.
So on 9, like, I'm just confused how you know you could like take, I don't know, like on 9. Okay, actually, could we just do it? I don't know.
I guess. Teenagers. Number 9 says x squared plus 8x plus 19 equals 0, right? So what's A? B is, C is. So I'm going to get what? Anybody got this? What's my...
Negative 8 plus or minus 64.
Now, go 8 squared minus 4 times 1 times 19, right? All over 2 times 1, right? So it's going to give me negative 8 plus or minus whatever that is over 2. What's this now? Negative 12, right? Now, right now, I already know what. But I know I'm going to have an I in my answer. If I don't have an I in my answer, I've done something wrong, right? Now, what I would do is I would take this out right now and make sure I've got my I out front. And then I'm going to break my 12 down, right? It's what? 2 squared times 3. That 2 is going to whoop out, right? So I'm going to have what? Negative 8.
Plus or minus 2y.
All over 2. Now, I should be able to see, based upon what we did already, is that I can take a what out now? I can take that 2 out, right? Well, what's that going to leave here? Okay, remember, when I'm taking it out, what am I doing? Dividing, right? So I got negative 8 divided by 2 gives me negative 4 plus or minus. The 2 is now gone, but I've still got my I roots of 3. That 2 I took out did what with that 2?
Divides out.
Starts with an R. Reduces out. Thank you, leaving me with negative 4 plus or minus I roots of 3. Did anybody get this right?
I didn't simplify.
Yeah,
And that's what I'm confused about. I'm confused like where you simplified 2.
To the negative 8 and
Can I go further than that?
So you just simplify all the way down.
Yeah, you simplify as far as you can.
Don't you? Yeah. So, would it be wrong on the test if we didn't simplify it all the way down?
Yes. Okay, yeah. This goes back to something that I said probably first week of school. A fraction that is not reduced is wrong. Okay, if I can simplify it, I must simplify it. Okay? Piece of lint floating right here. Okay? Alrighty, so that is that. So that post score is going to be due Tuesday before class, right? Along with the pre-score for 4-3. Right?
Yeah. So when you're seeing if you can simplify it more,
Yeah.
it doesn't have to go.
It has to be.
It doesn't have to be able to go into the.
No, the radical does. No, this will never change. That's why it's got to be there, in front of the radical, and in the denominator. They're the 3 places it has to be. Okay? Alrighty, so Unit 4-3. Here we go. So it is still the 6th. It's actually my mother's birthday today. I already called her. That's right. I'm a good son. That's a lie. I'm not really the good son. Actually, I might be.
Please.
Wait, why do we have 2 after ours?
Because you had secondary math 1 last year. And then next year you're probably going to have secondary math 3. See how that works?
Yeah, why did they change from like...
I don't make up those rules. I honestly don't know. I assume they felt when they went Common Core 8, 9 years ago is when they did all that. Yeah. I assume it's because they felt it was better. I don't know. I wasn't on that committee. I assume that was like a state school board thing.
Which one did you like better?
I like the old way. Yeah. You taught like Algebra 1, then you taught geometry, and then you taught Algebra 2. So like you could be through Algebra 2 as a sophomore. Then you take pre-calc and calc, or calc and AP stats, or you had more flexibility. But I don't know. I guess they felt there was some state back east that did this and felt it really worked well, and so we adopted it. You know. All right. So our objective is going to be able to properly solve any given quadratic equation. Now I don't know if any of you have a really good memory, but that should look what? Familiar. Why? Because isn't this almost the exact same objective from... Anybody have the objective from the other day? Does anybody write them down?
Yeah.
Probably solve any given quadratic equation.
Oh, wait. Well,
4.2?
yeah.
Probably use the
4.1.
quadratic formula to solve.
Okay, so now here's the difference. Is we're still solving what? Quadratic equations. But we're going to do it a different way. My hoagies analogy, right? Okay, now, so if you go back to something I said the other day, Barker, okay?
They're all good for different things.
Exactly, right? I'm going to hoagies. Okay, if I'm driving, my son's father-in-law's Ferrari, am I going to take the shortest route to hoagies?
No.
Hell no, I'm going that way. As far as I can. And then I'll go that way, and then I'll come back to hoagies, right? Okay, if I'm riding a bike, am I going to go that way? No, I'm going to take the shortest route. You know what I'm saying? They're all good for different things. And the key, really, when we're done, the key is going to be to look at a problem and say, you know what? The best way to solve that is this. Because once you've done that, the rest is just a bunch of math, which you can learn. But it's determining the best way to solve it that's really most of the battle. So, what they're going to do is this. They're going to give you something like this. Let's say I've got 3 times x plus 1 squared minus 7 equals 12. Okay, now, what is different about this than what we did last time? Say it louder. It's not in standard form. I don't have an obvious A, B, and C. Now, could I put this in standard form? Yeah, I could. But, again, that would take me a bunch of extra work at the beginning just to get it to where I would do the work I'd already done, right? So in this one, this is what I would consider, and I don't know the best name for this. This is what I refer to as just a straight up solve, which means I'm just going to try to solve for x right now. Okay, now, you've got to go back and remember this stuff. Okay, do we all know what PEMDAS is? Yeah, okay, but remember, it's opposite of that.
Yeah, I got thinking about that yesterday, and when you do it to try and solve like for 0, I was like, why do we do it the opposite way?
Okay, so that's actually a great question, because if you think about it, you were taught that in maybe 4th or 3rd grade. Anybody remember?
Yeah, but you would do the 7 first.
Exactly. I would do, but now I'm not doing that way. I'm doing the exact opposite of that.
Yeah.
So instead of adding and subtracting at the end, I'm actually going to add or subtract at the first, because I'm doing basically opposite of what you were taught. Because back then they didn't have any what? They didn't have any variables. What was that?
What?
What was so funny, Smedley? I didn't hear it.
You're like, what did they not have when Tyler was like, knowledge? And I'm just like,
Well, there's a few. You had definitely not very much, but not necessarily you, but you were like in 3rd or 4th grade, right? Okay, I didn't mean that by him. I meant that you as a class. Now, so because now they added variables that I'm going to solve for, I've got to do it basically backwards. Okay, so if I want to solve this for x, what does that really mean? I'm going to get it by itself, right? I'm going to isolate it. So, what am I going to get rid of first? 7. So I'm going to Add 7. I'm going to add 7. That's going to give me 3 parentheses x plus 1 squared equals. Ah, shit.
Then I'm supposed to equal.
No. 9. Make this a 9. Sorry. Make that a 9. I just don't want my first one to be ugly. So I'm going to get 21, right? Okay. What are you whispering, Graham?
Sorry. I was just saying I'm gonna watch that again.
It won't be the last time I swear in class, I promise you.
Okay.
And I used to try. I really did. I used to try really hard.
Not to swear.
What'd you say, Smedley?
I said to swear?
Wait.
I'm just confused what you're saying.
She thought you were saying you were gonna.
No, I used to try really hard not to swear. Because my wife was like, Shane? You know, and then I realized it's going to happen. I'm sorry. I just, it just does. In fact, I'm not even sure I'm sorry anymore. I'm 50. What are they going to do? You know? I mean, David's mom's going to chew me out on Sunday. I don't know. Okay, so what am I going to do? Yeah, because I'm solving for x, right? I'm isolating my x. So I'm going to divide by 3. I'm going to divide by 3, and that's going to give me x plus 1 squared equals 7. Then what?
You're gonna square root it all.
I'm going to square root it, right? So I'm going to square root it. Square root that side. I square root that side.
So you know this root.
Over here, I'm going to get what?
Why do you square root x plus 1?
Because that's square.
Well, so remember, I got to get my x by itself, but before I can get my x by itself, I got to get it out from under that exponent, right?
X plus 1.
So I'm going to get x plus 1 over here. Over here, I'm going to get what?
Isn't it just like that? Wonder seven.
It'd just be 7.
It'd be the square root of
Just kidding.
It'd be
No, it's just be yeah. Just that.
Just square root of 7.
Wait, no.
It's negative.
Nope.
Square root of 7.
Oh, plus or minus the square root of 7.
Nice. Why is it plus or minus the square root of 7? Exactly. We went over this the other day, didn't we? Because we are doing what? What?
Oh,
We're
yeah.
square rooting to solve the equation. What did I teach you the other day? Anytime I square root in there to solve that equation, I'm going to get the plus or minus because, as Flinter pointed out, I don't know which one it is. We did talk about that the other day, didn't we?
Yeah.
Okay. Did you?
Well, I don't know. I just, like, what if it doesn't come back with anything like in the square root bars?
What do you mean?
Like, if the number was 16 or something? would it
Still, it doesn't matter. You're still going to have plus or minus.
And it has always been like that because I've never done that. So have I always been doing it wrong? Or is it just like this type of equation?
Well, it's okay. So what you're confusing is just regular math,
Yeah.
right? We're solving quadratics, which are going to have an exponent in it. You go back to all those other just 3 or 4 step equations you were solving as a kid. They didn't have what? They didn't have exponents in them. Do you see the difference here?
Yeah.
Yeah.
But when we were like in like 7th and 8th grade and we were learning equations, they do like x squared equals 9 and
Yeah.
it's always 3 and it was
Okay,
like
but that okay, so that was wrong.
Oh.
so they just never told us.
Well, but the problem you got to understand is it's about levels of understanding, right? And when you were in 7th grade,
Technically, it was the right answer, but only one.
exactly. That's okay. That's a great way to put it. You were halfway there,
Yeah.
It
right?
was right.
But ultimately, does that make sense?
Yeah.
We're just adding on more, you know. It's like when you were a kid, you just, you know, you like just Cheerios, right? And then they came out with Honey Nut Cheerios because they had more, you know what I'm saying? We're adding on. Wadsworth, did you have a question?
No, I'm good.
I didn't dispute that, but did you have a question?
No.
Oh, okay. Now what do I do?
Subtract 1.
Yeah, now I'm just going to minus 1. Now watch. Where does that 1 go?
Behind it.
Behind it?
Yes.
In front of it.
What if it was a plus?
No, it doesn't matter. It goes in front, which is why the plus or minus is there. You know, right?
Is it because of standard form?
Well,
just wanna look
No,
like-
because that's how I'm going to get my two answers. I'm going to get -1 plus or minus the square root of 7.
Oh, because it's not plus or minus negative.
Exactly. It's plus or minus the square root of 7. So you're going to get -1 minus the square root of 7, and then -1 plus the square root of 7, and they would be your two answers. But going back to what somebody asked over here, I would leave it like that because I'm lazy. Yes, Peterson.
So if it was the square root of 16, would you put plus or minus the square root of 4? Or plus
No, I would be just plus or minus 4. Was there somebody over there? Can I help you?
Who's at the door?
I'll come back when you're not so busy.
No, you can come in. These kids understand.
Studious group.
They are. They're pretty good. A couple of them are secondary math 2 honors. Smart kids.
These are all the brilliant ones.
Well, I'm not sure I'd go that far.
They're the wannabe brilliant ones.
There you go. What's up?
Hey, I'll catch you after. Just remind me to. I had a visit with you. It's nothing major, but it's something to think
Am I in trouble?
No,
Oh.
not at all.
Because I'm 50 and I still, every time I get it, hey, Mr. You come to the principal. I'm like, what did I do
You
now?
don't need to be nervous about this.
Okay.
You wanted a few days off. Sorry, like you're still here, stuck working.
Yeah, I'm not.
Am I gonna get the call? It's like, hey, you take like 2 weeks off. No.
Yeah, no, I don't want one of those.
No.
My college algebra class, I had 41% in one of my college classes today out.
Wow.
That makes it tough in a class like that.
It's hard. It's hard on everybody.
Yeah, it sucks.
This class is almost full. Missing 3
Yeah.
in the back, huh?
No, that's empty. The first time I haven't had 40 kids in this class in a long time.
Good.
So
Secondary math honors too. Good.
I'll come down when I'm done teaching.
Yeah. Just
Okay.
ring in, man.
Okay.
I had a thought, man. Like, I
Okay.
need to
Yeah.
visit with you.
Alrighty. So from there,
Wait, if you had that problem without the +1 there, so like your answer is just plus or minus square root of 7, is that okay? If
Yeah.
You don't have a number in front of it?
yeah, that's fine.
But
That's
you don't
fine.
need to put like a 0 or
No,
something, so it's
no, 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 doesn't matter. Smedley.
So can we just
Shh.
simplify it down to like -1 plus the square root of 7 or -1 minus square root of 7? Or could we just leave it -1 plus minus square root of 7?
We've already established
said
this.
at least 3.
You can leave it.
Yes.
We
Yeah.
Leave it.
You're never gonna change that?
we
He
took.
said it's
Didn't-
okay because we're lazy.
I know, but sometimes.
Now listen. When? Okay, no, it's a valid question. When would it be required to do this? No, no, no. This, no. Listen, this tells me the same thing. But what if it was like this, like Peterson suggested? Let's say I had this. What if I had it like that? Then I can simplify further. I can't go past this, can I? So did this do me any good? No. Can I go past this? Yes. -1 minus 4 and -1 plus 4. I'm going to simplify that. That's going to give me -5 and 3. You see what I'm saying? Then I'm going to go there. But if it doesn't do me any good, why go through the extra effort? You know what I'm saying? Because I know that means that. I don't need to spend an extra 30 seconds on every problem to do that. Does that make sense?
Yeah.
But if I can do it, then yes, I do need to do it. Do we all understand that? That was actually not as stupid as question as you all thought it was. Yo.
Are these
Oh, don't flex on him. No, I saw that. You went, yeah, I saw that. Yeah, I didn't, whatever. She's like, that's right. That's right. I don't know how that feels because I'm married, but you know. And if you didn't get that, that was funny. I mean, funny. Because I'm always, yeah, so you get it now. Just took you a minute, but it was funny. Yeah. Was there nobody? Alrighty, so let's say I did this. Let's say I said 7 times x plus 2 squared equals 14. Okay, let's say I go there. Okay. Now, It's a little different, but it really doesn't change the mechanism here. Okay? I don't have anything to what? Add or subtract, so I'm going to go right to the, I'm going to go right to the divide 7. Because remember, I'm trying to get my x where? By itself, right? These are going to reduce out. I'm going to get x plus 2 squared equals 2, right? Then what am I going to do? Square root both sides, square root that over here. I'm going to get just what? X plus 2. Over here I'm going to get.
Plus or minus square root 2.
Okay, then what? DUN. So, here's a funny story. Halloween, I went out front and there's a pumpkin sitting on my porch. And what?
Was it yours?
No. And on the front it says, "Thank you for being a teacher." Or something about, "Thank you for teaching me math and chemistry," or something. And on the back they wrote that. It was funny, yeah. Yeah, I laughed. I thought, clever.
How do they know where you live?
Because I live in the community. Like David's my neighbor.
David, where do you live?
Oh. Do you know my grandparents?
You don't need to answer that,
David,
David.
you live right Denton.
Bruce and Ann.
Oh. So is Chad your uncle?
Yeah.
Oh.
Yeah.
I do know them.
Did you coach Chad?
I did. Yeah, he was a great kid. He married a real skinny blonde, right?
Huh?
Didn't he marry a really skinny blonde?
Yeah.
Yeah. I don't remember her name, but I know she went here too.
Yeah.
Yeah. Like, Stoker doesn't live that far from me either. Hess, you don't live that far from me either, do you?
I live closer than Carson. I live closer than
Do you?
Yeah.
So it's not like it's a secret. People know better, though, than to mess with Mr. Denton. I'm just saying. You know.
Has anyone ever like toilet papered you or eggs?
I got boxed once, and it was funny. So back in the day, they got a bunch of fridge boxes, right? And they rang the doorbell, and then they all hid underneath all these boxes out on my front lawn, right? And I come out, and I'm like, "Oh, that's clever." You know, that was all. So then I go back in, and then they do it again, and by the time they ring again, they all move. You know what I'm saying? So it's like they're playing like musical whatever, right? And I'm like, "That's clever," and I'm a teacher, so I get this, right? So then they do it again, and I'm like, "Okay, now we're reaching the limit where it's not funny anymore." So I take my shotgun out there the next time. Hey. And it was empty, but I just, it's a pump, so I rack it, right? And I mean, whoosh! They just disappeared. They were gone. And I'm like, "That's right, I got the last laugh." Yeah. And, no, I ain't stupid, but it would have been funny. Okay? But yeah, needless to say, I scared the shit out of some sophomores that day. You think they ever mess with Mr. Denton's house again? No. So yeah. Next day I come back, I'm like, "Oh, where are all my students?" But yeah, it was funny, you know.
Wait, did you ever figure out
Yeah. They were. It was funny, yeah.
How long ago was that?
Oh, it's been 15 years. It's been a long time. Yeah. Yeah, I mean, it's the same idea where you hide in it, you know. They just use big boxes so they could stand in, and then the minute the door would shut, they would move, and then some brave soul would ring on the doorbell again. And I mean, it was, you know, for the first 3 times, it was funny. And then it gets old. You know, I'm trying to watch, you know, MacGyver or something. I don't know. Yeah.
So are these still points of a problem?
Now, they are. Okay, so here's what you need to understand. And somebody, I don't know if it was this period or the other period. What you would need to understand is that this is what is referred to as an exact answer. And that's what we're going after right now. Now, if I really wanted you to put this on a graph, then yeah, I'd have to figure this out. And then that's where I would graph them. But you're right. It's still, still the same thing. Yep.
The zeros.
Yep. We're just leaving them as exact instead of. Because anytime you put a radical like this into a calculator, you're going to get an approximation, right? You're going to round it.
Yeah, that's
But for right now, we're staying exact, which is why we're leaving it that way. That's a good question as well. Okay, anybody else got a question here? Or is this making sense? There you go. That's where we were going next. Good job, Dixon. Alrighty, so let's do this.
You know me. Is that a 4 or a 9?
That's a 4.
I knew it was a 4. I knew it was a 4.
Okay, I want 15 hands. Okay, so we got 1, 2, 3, 4. Barker, you're 5. You're 6 gram. 7. So hey, right here, 8, 9, 10, 11, 12, 13, 14, 15. Okay, here we go. Hadley, who is that? Right next to yeah. Oh yeah, yes. Okay. All right. So who was 7? 7, Smedley. Okay, talk to me. What do you got?
So I started by subtracting 12 from both sides.
Okay. Okay.
And then I divided 3 off both sides. And then I square rooted both sides and got x minus 4 equals plus or minus 2i.
So she went right to the simplification, right? You can do that. Okay, then.
And then I added 4 to both sides and got x equals 4 plus or minus 2i.
She right?
Yeah.
Get to it.
Well, that's, I was confused though. I'm not sure. Would you take like the 2 after?
Because if you did that, it'd be 2 times 2 plus or minus 2i. Is this simpler than that?
Well, technically, wouldn't it be just 2 plus I?
Hey.
Because you have the square and you like multiply and you square 4, negative 4, right?
That's where she got the 2i from. Pulled the I out, pulled the 4 out as a 2.
the left side.
Over here?
You square root it.
No. That square root got rid of that and left this. That and that go away. Does that make sense? Anybody else? Okay, let's get after it. I am going to run down and talk to